So what we're looking at today is lesson 8, relating area to circumference. So let's go ahead and jump right in. All right, so for this first part, we have a circular field that's set into a square with an 800 meter side length. Estimate the field's area. Well, first of all, we're estimating. So that means we do not have to have an exact answer. We are taking and finding an estimate or an approximation of the field's size, the area of it. Now, being as the circle is contained within the square, we know that it has to be smaller than the area of the square. So we could find the area of the square, and that would give us an approximation on the size of the circle, the area of the circle. So to find the area of a square, we take 800 times 800. Sorry, marker's really fine, isn't it? And so 800 times 800 equals 640,000, and that'd be meters squared. And so we know that this is bigger than what the actual circle is, because obviously we have all these parts on the corners where it doesn't line up, so we know it's going to be smaller. So if we look, we've got 5,000. Well, that's way too small. We've got 50,000. That's too small. We have 500,000, which is fairly close. And then we go to 5 million and 50 million. Well, the 5 million and 50 million are bigger than our estimate, so we know that's wrong. So it's going to be the 500. Now, another way we can check this, the radius of this circle is going to be half of the square's side length. So that means it's 400. So finding the area is going to be, we're going to square 400. So 400 squared is going to equal 160,000. And so we know we have to multiply that by pi, and that's going to get us close to our 5,000. So we know it's got to be bigger than this 160,000 because that doesn't take into account pi, but it's got to be less than the 640,000 because that's this whole square here. So we know that information there. All right, so the next thing we're looking at, it's coming somewhere. So this is all showing how we can take shapes and split them apart and form other shapes. And the more parts we make in a circle, so like in this one, we split it into fourths and then put the fourths together, and we have a very curvy shape. But here we divided it into 1, 2, 3, 4, 5, 6, 7, eighths, and it gets closer to being a parallelogram. And then here we divided it into even more. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 16 parts. And so we put those together. We're really close to having what appears to be a parallelogram. So we can relate circles to other polygons. So just like it says here, making another polygon out of a circle. So imagine a circle made of rings that can bend but not stretch. So there we can open it up, but we can't stretch it out to make the sizes different. So we're not going to change the sizes of anything here. So a circle is made of rings. The rings are unrolled. Oh, sorry. The circle has been made into a new shape. So we took the circle made of rings and we kind of just opened it up until we had a flat side. So what polygon does the new shape resemble? So if we look at this new polygon over here, what does it resemble to you? Now, it's not going to be exact, but hopefully you're saying it looks like a triangle. So we've got a base, and then we've got our two diagonal sides coming to a common vertex. How does the area of the polygon compare to the area of the circle? Oh, excuse me. I choked on my own spit. Ooh, okay, sorry. So how does it relate? If we look at the circle, all we did was open it up. Did we change anything about it? Did we stretch it? Did we shrink it? Anything like that? No, we didn't. In dimension-wise, all we did was open up that circle and lay it out. So all those rings were now flat instead of being smaller circles. So all these pieces are the same size over here as what they were over here. So that means the areas are equal. Oops. Hang on. Why is it not writing? Partially right. So areas are equal. How can we find the area of the polygon? So what's the formula for finding the area of a triangle? Area equals 1/2 base times height. So that's our formula. So now for number 4, we want to show in detail steps how we could find the polygon's area in terms of the circle's measurements and show our thinking. So we're going to take and write what this would look like out. So we'd take our area would equal, now this bottommost color, so we're using our triangle formula. So area equals 1/2 times our base, which is this kind of green color, which notice that's the outside of the circle, which means it's what part of our circle? It's the circumference. So 1/2 times C times, what's the height? If we look at this in terms of the circle, what value is the height? It's going from the center to the outside edge. It's the radius. So we're just going from what our base and our height are to what those are represented in the circle. So we've got our circumference, we've got our radius. So now circumference, we know the equation for that. 1/2 pi times diameter times radius. Now, we know the diameter is 2 times the radius, so we can say that this equals 1/2 times 2 pi r times r. Now, the 1/2 and the 2, what's going to happen with those? They're going to cancel out. So now we have pi times r times r, so we have pi times 2 of our radiuses. So if we multiply r and r together, the radiuses together, what happens? What happens when we multiply a variable times itself? We get, I don't know what that just did. We get pi radius squared, and that should say pi radius times radius squared. I don't know what it's doing with the connecting, but that's a pi right there, just so you know. So it's our pi symbol. So pi radius squared. So the area for a circle is area, I don't know what this is doing, area equals pi r squared. So that's the area of a circle. So that's, and we showed how it went from that triangle that we had and worked itself out to give us the area of the circle. So we can see how they're related through all of this. So we're looking a lot at area, so finding the area of our circles, and this is your formula for that. So this formula will be key in solving. So you're going to take whatever your radius is and square it and then multiply that by pi. And yes, it has to be the radius. You do not, under any circumstances, want to use the diameter to solve for this. It's not going to give you the right answer. You have to figure out what the radius is to find the area, okay? All right, your keyword for this lesson is area, area. If you have any questions, feel free to ask. Have a great day, guys.